All right, so we're here on our PropTech podcast. I have Tristan De Frondeville. He's the CEO of Skycentrics, and we're going to talk a little bit about PropTech and where he fits into the industry. Yeah, you want to give us a quick intro on Skycentrics?
Sure. So, typically there's two divisions between PropTech. There's the construction side, commissioning, you make sure the building works, and then there's the operations side for the next 50 years, potentially. So we've been on the operations side. You may be more familiar with construction side. I think I'm going to be talking about how one of our goals is to actually bridge both, but we're definitely on the operations side. We started, interestingly enough, from the grid. We realized that the grid was going to require machines to go on and off at the right time instead of the random time. So your thermostats, your big machines that make hot air, hot water, cold water, they're really valuable, just like batteries in cars and EVs, when they can use more energy when the grid is clean, full of renewables, less energy when the grid is dirty and expensive, and that's where we started. But in the process, as I'll show you, we ended up learning how to connect to all the machines in commercial buildings, all the systems, and believe it or not, it's an incredibly old industry with old tech. So we're bringing modern tech, and obviously we're supercharged now because of AI, right? So if you want to apply AI to buildings, which are using 35% of the world's energy, emitting 35% of the world's carbon, then you want AI to help. You want AI to help with all that orchestration of what I talked about, using more energy at the right time. So that's what we're focused on. That's what we're bringing. We've brought to market. We started in the grid, but the commercial building side, we call it the unprotected hill, right? Less than 2% of commercial building equipment and machines are connected to the internet. So we connect them to the internet, and we bring the power of AI to orchestrate, optimize those buildings, and lower their total cost of ownership. Not just energy, but capital expenditures, operations, maintenance, everything.
So who would you say is like your prime target for clients? Is this like large multi-units? Is this industrial?
So you typically split buildings up into residential, but multifamily starts crossing into commercial. And then you've got commercial, everything from office buildings, now data centers, hospitals, et cetera. And then you have C&I, right? Commercial, industrial, factories. And believe it or not, we can now connect to anything in any building. We've kind of left residential behind because to orchestrate a residential home, we think that long term it's going to be Apple, Google, and Amazon, right? You already have the universal remote for buildings. For residential in those voice-controlled systems. Whereas, as I said, less than 2% of buildings are connected and can do that. So, but you mentioned industrial, and we have some very interesting use cases around industrial.
Interesting. So, yeah, this is kind of new to me. I've recently been looking into a lot of the sensors and different things. So, could you give us like a basic example of like an application of sensors, or what would be the objective, how they do it, what's the objective?
Yeah, so when people think of sensors, you might think of occupancy sensors that are with lighting systems. So what we do, and a little history, right? So it started off that the utilities 15 years ago said, hey, we see a world, not just Skycentrics, where we're going to need to connect to these equipment loads, electrical loads, and be able to send them signals that say, hey, use a little more energy now, use a little less energy now. And they went to the water heater manufacturers and the HVAC manufacturers, and the HVAC manufacturer said, okay, we don't have connected water heaters right now, but if you want to connect to water heaters, then how do you want to do it? Utilities. There's 3,000 utilities in the United States, and they had a lot of different answers. And the water heater manufacturers said, well, we make 9 million a year, and we can't make 9 million Wi-Fis and 9 million cellulars and 9 million other. So we need kind of a USB communication stick. Remember when laptops, you had to plug in a stick? It didn't even have Wi-Fi on board. So we need that kind of a concept. So the utilities came up with some of their research organizations with this EcoPort USB port for machines. So we made a module. Skycentrics was one of the main developers of this concept, and we made a USB stick for machines, right? Plug it into the USB port, USB stick, and you could have Wi-Fi and cellular and all that. And imagine if you were the expert in a USB stick for laptops, and there was no USB port in laptops, except for pilot quantities, research quantities, like tens or hundreds. But all of a sudden, Washington and Oregon 3 years ago passes a law that says every new water heater in Washington and Oregon has to have this socket. So all of a sudden, everybody got a lot more interested in what we were doing. Then, in the commercial building space, they started saying, hey, commercial buildings don't have connected machines. They use a lot more electricity, those big things on rooftops and in basements. So they want this port. And meanwhile, all those machine makers, Daikin, Mitsubishi, well, that's not what they've been doing for 30 years, 60 years. So we made this box that talks their language from those machines and gives them this USB port. So that's what we were doing. And then we have a Skybox. Can you bring me a Skybox, Super Skybox, Opera Tim? Thanks. And then we actually made a Skybox that could connect to any equipment in the building and any system and actually bring in the full power of a Linux computer. So this has a small Linux computer, and that's what's revolutionizing this building space. We can pull the data and deliver controls back to any system, any machine in a building. Super exciting, bringing the power of AI to the building, making it visible. Thanks a lot. Yeah, anything. So this is the magic thing, a Super Skybox. And this plugs in, little thing, but it's a real computer, Linux computer, based on open standards, just like this, right? USB, open standards. And all of a sudden, you can connect to any machine, any building. And believe it or not, there's this great clip of an engineer saying, you know, I just wish I knew that things were kind of okay. And that's what they can't do. If you want to see whether a piece of equipment in a commercial building's working okay, most of them, 85% of them, don't have any connectivity in the building. You got to go to the machine like SneakerNet in the old days and look at a little DOS screen, monochrome, and look at the menu and see if there's a problem. Then 15% of the buildings have the big 60-year-old systems from Johnson Controls, Siemens, Schneider, etc. And they say, oh, well, we can connect to the building, but they're not modern. They're old tech. And they're not modern computers. They're expensive proprietary systems that have only penetrated 15% of the commercial building market. And that's in the United States. You can imagine Africa, China, they don't want to spend all that money. So we basically plug this into the building. Sorry, make it pull back. And now we're bringing all the systems, all the machines into one place. The building, so you asked originally, who's the customer, right? And yes, we are selling to building owners individually, especially when they own hundreds of buildings. But what we're really excited is we're developing the tools so that everybody who already delivers services to those buildings, that's mechanical, electrical, plumbing contractors, architects and engineers who design the buildings and recommend new retrofits for new systems, and finally master systems integrators who do some of that 15% of the building connectivity. And we're building the tools so that they can immediately sell it to their customers. So that's kind of what's exciting, right? Because the owners are dying to see their buildings. They can't see them on their phones. They can't open a laptop and see their hundreds of buildings in one place, make sure everything's working okay. Like that engineer said, I just want to know everything's kind of working okay.
Yeah, it's interesting. So I could just imagine from a technical standpoint, the coding or the connectivity to so many different machines. So like each manufacturer is going to have their own error codes and different things. So the technical aspect of this had to be like astonishing.
Well, believe it or not, right? The good news is they were already talking for those building management systems from Johnson Controls, Siemens, and Schneider. They already kind of said, okay, there's a 60-year-old computer in the building, and we want to make it so that our machine can at least be talked to by them. So the weird ways they talk are Modbus and BACnet. You've probably never heard of them. And imagine trying to, invent a way to connect to machines and buildings 60 years ago, machine to machine communication. And, a funny aside, the first Internet of Things was 120 years ago when you had thermostats in a building that needed to talk to the boiler in the basement and say, hey, I need more heat. Do you know how they did it then? I don't want to quiz you. It's pretty funny. It was Harry Potter. It was compressed air. I've been to the buildings on Sand Hill Road where the VCs are, and they still have compressed air thermostats. But in the 60s, Johnson Controls and Siemens said, hey, we'd like to use this thing called electricity. So imagine inventing machine-to-machine communication in the 60s. And that's what they're still using now. But it's Modbus and BACnet, and our computers just had to learn how to talk Modbus and BACnet. And then the magic of the last 2 years is we can ingest all of their manuals, because you talked about error codes, and we just ingest those into a big, large language model, essentially for buildings. And now we can answer questions about all those things by just Chat GPT for buildings on our platform.
Wow. So yeah, now the world we live in, we take for granted like a Ring camera, for example, like what's going on in my rental property 100 miles away. And like, yeah, if you own big buildings, industrial, commercial, whatever, it'd be nice to look at it and say like, hey, floor 17 is not flooded, or it's a normal degree, or whatever.
Well, I'm glad you brought up the home example, right? Because we're so used to it. And imagine that the people who own the buildings have enough wealth to have pretty nice connected home equipment, and they're still like, how come I can't see my buildings? Or why can't my team see my buildings this way? They're just flabbergasted. So they're super excited that they're finally going to have, as one of our facilities managers said, who clearly used to be a Marine, I want situation awareness.
Yeah. What's going on? Especially like I'm in South Florida, like hurricanes are different things, like it would just be nice to know what's going on if you evacuate. So the next thing I kind of curious, like, so with for the example I'm more familiar with, multifamily homes, cap rate, for example. So are you more related? Do you think it's more geared towards regulatory stuff or like profit? So like helping building owners, for example, shave off 1% of the operating cost? Or is it more regulatory, like to abide by state laws or things that are coming that are energy consumption related?
Well, there's no doubt that, certainly until this administration, there was a lot of regulatory wind in our sails, so to speak. There's a little less of that, but we feel like the most important thing that people want, especially when office buildings were losing tenancy, is total cost of operations reduction, right? So the minute you have visibility, you can at least have a sense of it. By the way, as you know, right, do you know when a piece of equipment is not working very well in your home? Well, you can kind of hear it maybe. You hear the fan going wrong. It doesn't work as well. But in buildings, they just get these electric and gas bills, and they really have no idea why. 1 month it was bigger, 1 month it was smaller. 3 months in a row, really big, they start saying, hey, what's wrong? And they send people around to look at the little menu of every machine to see which one's being weird and causing them so much electricity and gas bills. So yeah, we're definitely focused on that. Although the regulations, so there are companies, for example, I'm sure you've interviewed some that are focused on regulatory compliance, and that's definitely not our thing for now.
So it definitely can help like profitability for these companies, like especially like you mentioned, people have 50 or 100 buildings. Like I can imagine those numbers could be pretty large if everything is inefficient.
Yeah. So you're a multifamily. You've mentioned it a few times, kind of that's a space you know. So I'll give you an example that combines kind of the regulatory and the cost. So Denver passed a law for Denver requiring this port on new construction multifamily water heating systems. And power to Denver. They also said it a lot of times, like the Washington law just says it has to have the socket. But it's not connected, right? It doesn't have to have the module, just the socket. Now, the good news is there's 250,000 water heaters, residential mostly, that have been sold into those two states, Washington and Oregon, in the last 3 years. Multifamily, as you know, can sometimes have water heaters in every home and be sub-metered, or they can have central system water heaters that are kind of either for common areas or going to every apartment. It turns out that in sort of low-income housing and, NYPA, New York Power Authority, and New York City Housing Authority, they typically don't have individually metered apartments. All right. Denver, because of the office space situation, there's being more and more conversions of office space to residential, right? And they got a grant from the federal government, but the federal government grant said, you can charge only so much rent. And they called us because Denver required connected water heater systems. So it turns out that we can put a connected water heater system in, whether it's central or individual, and then orchestrate the water heaters so that they're not all coming on at the same time. Because what happens when they all come on at the same time? They all hit a peak. It's just random. They're going on and off random. Remember, I said we're specialists in making them come on at the right time instead of the random time. So they're going on and off randomly, and they suddenly are all on for 15 minutes at the same time, and you've hit a new peak. 40 to 70% of a commercial building electric bill is the peak charge. Doesn't matter how much electricity you use. They just say, oh, you hit a peak. That's a constraint on our grid. We have to make sure we have enough electricity for your peak. And for the next 12 months, you pay that peak because you hit it one time for 15 minutes. So we're able to tell those Denver multifamily properties that I just described that we're going to reduce their peak by about 50% because we're never going to let all the water heaters come on at the same time. Now, obviously, if we have more loads under our management, like HVAC or EV charging, we can do the same thing. So I hope that kind of showed the power of regulations, motivating certain things, but then the total cost of operations. And this peak demand charge management, managing solar batteries and EV chargers in modern buildings, it's all more complex and wanting more connectivity, more situation awareness, and more automagical orchestration.
I can see where you're pumped up for this business because I can just see in the future where it's going is before you know it, I think everything will be connected. Hot water tanks, air conditioners, microwaves, who knows, refrigerators. It's just a matter of time. I think the way technology is going before everything is just connected and kind of monitored for usage and whatnot.
And we've been, you're right, and we've been focused on the open standard way, right? So there was Microsoft and there was Oracle and there were others that had their proprietary servers, but Linux won the internet battle, right? Every server on the internet is just about run by Linux. So the Linux Foundation, just 2 months ago, merged with the Coalition for Smarter Buildings Foundation, which was promoting plug-and-play open interoperable systems rather than one building has Siemens, one building has Schneider. Drives everyone crazy. You need a Schneider specialist and a Siemens specialist. So this Linux Foundation initiative is super exciting. It's about open source and open standards. That tends to lower costs, increase cybersecurity. And this box that I showed you is the first interoperable building box blessed by the Linux Foundation. So as you can tell by this open standard socket, we're a big king of open standards, and we think that's going to make a big difference for building owners to feel comfortable that they're doing something that's long-term, interoperable, works nice with other systems, not just sort of another proprietary, siloed, single system solution.
Yeah, like they're going to have to change everything out in a few years. Like it's nice having the standard, the open source. What's kind of your background before all this? So you I think 2012, 2013, you got into this. What's kind of your background?
Yeah, well, I graduated college with a math degree, juggled in the streets of Europe for 2 years, and then was a high school math teacher, and then developed software teams. And obviously, once I was developing software teams and doing software development, that was tech. So about 20 years ago, 25 years ago, shifted into tech.
In Silicon Valley there or in
Yeah,
California?
yeah, San Francisco, heart of tech.
Nice. So, what trends excite you most right now for this industry?
Well, as I said, an open source, plug and play, interoperable solution for buildings that brings the data to one place in a standard way that is a modern computing stack. The Linux Foundation has different projects. So there's the IBB project, the Interoperable Building Box project. There's the Open Building Stack, which is the tech stack that we're putting on our computer, on our IBB, on this little interoperable building box. And, we think being part of that effort is really exciting. Now, the other exciting thing, which obviously is a little less important right now, but in the United States, right? Europe, the world still going strong. Electrification, decarbonization. Let me ask you, Alex, have you sort of heard about the heat pump miracle?
No, not in particular the heat pump miracle.
Right. So you put in a water heater, you put in an HVAC system, you put in a gas boiler in a building to make hot water for lots of people's and apartments. And all those machines that we've used for the last 100 years can get to 99% efficiency. You're definitely a little younger than me, but I remember when I was young, every hot water out at every friend's house and my house, you would put your hands in and it would be boiling hot, and then you'd have to mix cold. And then the Energy Star program came in and started talking about efficiency of water heaters. And I don't know if you remember going down to seeing really thin old water heaters because they had no insulation, and now they're big, wide, and fat because they have insulation. So Energy Star in the last 50 years brought water heaters from about 60% efficiency to 98, 99% efficiency. Super exciting. But that was the efficiency you could get with physics. You have a universal, always running machine that it's impossible.
Mm-hmm.
But a heat pump is 300, 400% efficient. Well, how do you do that? It's because it doesn't make heat. If you make heat, physics says you can only be 99% efficient. But if you move heat that already exists, well, that's just a question of fans and actually kind of the air conditioning compressor idea. A refrigerator does it, right? A refrigerator moves heat out of your refrigerator into the air. If you're on the back of your fridge, it's blowing out warm air. So a heat pump can be 300 to 400% efficient, plus it's electrical, plus it can move the heat in either direction. So you can get air conditioning, which New England never needed before. It's suddenly been wanting, everybody wants air conditioning, right? Even in San Francisco, where you don't need it very much either. So people are replacing their heating systems, 99% efficient, with heat pumps that are 300 to 400% efficient. But in commercial buildings, the heat pumps are more complex machines. What happens when it's more complex? When it's in tune, it's got those magical efficiencies. When it's out of tune, you're really spending a lot more money than you needed to. So what do you need? You need a connected piece of equipment that's letting you know everything's working okay, or no, it's a little out of tune. Go and fix it before you spend a lot of money. So electrification, decarbonization, again, wind in our sails, because a lot of equipment's getting replaced. Good time to put in a little skybox, but also because we're monitoring it and letting people know the minute it goes out of tune. You have a car, right? Look at all the sensors on your new cars. Aren't you happy when they say, hey, your tire's a little low, right? So you're avoiding a blowout in a new tire, you go pump it up with air. It costs you a little time. So that's the magic, right? Get things connected and have a lot less repair costs, a lot more understanding about your total costs of your building. And more importantly, if you've got old equipment, because our machine can talk to old equipment, then you can find out when that equipment, it can be replaced by modern equipment that's way more efficient and save you a lot of money. And you can calculate those ROIs. That's part of our platform as well. Capital planning.
Yeah, I'm glad you brought up the car analogy because I was thinking that the whole time where how connected the car is, sensors everywhere. And, for the past, I don't know, maybe 5 or 10 years, even apps on our phone that's like your tire's low, your oil pressure's high, whatever. And it just makes sense, especially maybe not a residential building, but like an Amazon fulfillment, or even better, like the data centers that are coming. Not a lot of people are aware, like the hurdles of energy consumption. It's just like massive because I follow that sector. And can you talk a little bit about like data centers, and like you probably plan to be in that industry, but can you talk a little bit about that coming
Yeah.
wave usage?
So what's really interesting is just 2 weeks ago, I read my first article because I follow data centers. It's kind of a big thing right now. And it was the first article that said, hey, this data center was permitted because, there's a lot of swirling around. Is it going to increase the costs of other residential people in that utility service territory? So this data center got permitted like a year or two in advance because they were saying we're going to be able to respond to grid signals and use less energy when you need it, utility, and more energy when it's freely available. And just because of that, the utility said, oh, if you do that, you can start 2 years earlier.
And just curious, like kind of a side note here, like energy production here is kind of flatlined. Like this topic I follow quite a bit. What do you think the solution is to that? Because, in the coming years, we need to like 2, 3, 4x, even 10x our energy production for AI and data centers. What do you think the kind of solution is that? Is it efficiency or just mass production?
So when you say mass production, are you talking about, hey, we just need to build more power plants?
Like some people estimate we need just like dozens or hundreds of nuclear plants to power AI and data centers.
Well, I mean, you can't. When you say that, I'm like, well, look at America and how we've been able to construct hundreds of big projects. It's hard, right?
Mm-hmm.
There is no doubt that this notion of virtual power plants, distributed energy resources, these are some of the languages around, hey, for once, connecting to machines and asking them to orchestrate and use more or less energy is efficient, inexpensive, and doable. And those machines are already all out there in our buildings, residential, commercial, and industrial. So there's a lot of research. We work a lot with national labs. You can imagine we're kind of at the cutting edge of a lot of initiatives. And the national labs and general researchers have shown that using these distributed energy resources as virtual power plants, where you can lower what other things are doing in order to enable other things to use more energy, is sort of a tenth of the cost of a new power plant. So, ideally, America is going to do what it does best, have competition, have lots of different things going on so that you can let the market figure out what's best and not make central system planning mistakes. So we think that what we specialize in, distributed energy resources, connected machines that can get those signals from the grid, has a lot of value. There's no doubt that we also need power plants. Ideally, we want clean power plants. If we can now make modular, safe nuclear energy, hey, hallelujah. And interestingly enough, somebody said, well, wait a minute, we've been making small, safe nuclear reactors for 50 years in nuclear submarines. Can't we use that technology? It's not my specialty, but I think a mix of both is really important.
After I asked the question, I felt so funny. I said, this guy, he can make everything more efficient, less waste. It seems like that's the obvious answer after I asked the question, like why not trim a little bit of the fat or the waste if you have the ability? That kind of comes, both sides, more production and more efficient. So what are the biggest challenges now for Skycentrics?
Well, as you can tell, right, because we're getting all that data from the machines, we really want to build the tools that enable our channels, our partners who have millions and even billions of square feet under management. We want to give them what we call our AI virtual engineering tool, right? AI enabled, AI enhanced virtual engineering tools where we enable them to deliver much better solutions at a much lower cost to their customers. We think that allows us to scale and bring this solution, which clearly the world needs, as quickly as possible. Well, that means we need to take advantage of our connections and really build out our AI enhanced virtual building engineer. Well, that means hiring more and more AI people, and as you know, they're pretty in demand. So that's a challenge, but we're excited about it. We've got some overseas teams that we've been working with for a long time. We really want to be having some American teams doing that AI, but we're going to be competing with Facebook and everyone else. So.
And when you say virtual programs and whatnot, you mean kind of like a user interface, or?
So what engineers have to do is they, again, right, everything from maintenance, which is pretty lower staff, to engineers who design the systems, who you call sometimes because something's really wrong and you need them to get involved. And the mechanical, electrical, plumbing contractors who are maintaining things, who would love to know before they truck roll to the machine what's wrong so that they don't have to do 2 truck rolls, right? They do 1 truck roll because they know what equipment, spare parts they need to bring. So that kind of virtual building engineer tool that says, hey, engineer, you can go look remotely before you do a truck roll at this machine, see how it's been working, get some of the alerts that you got in real time that things weren't working well, investigate, troubleshoot, do everything, ask questions of our little chat bot that's right in our platform, and then make good decisions. So it's a decision-making platform. Does that help?
Yeah, definitely. So like I'm always fascinated with data to make good decisions. And it's like there's data, and then there's data like, hey, you need this bolt at this location, opposed to like, hey, there's a problem over here, go figure it out.
Right, right. Actionable data that really helps reduce costs because it's detailed.
Yeah. And now AI just launches everything forward. Once it knows a model number, like even probabilities come into play, like, hey, this model, when things like this happen, high likelihood it's this issue or A, B, or C.
Yeah, Alex, I'm really glad you bring that up because, as you know, in the tech world, they've been doing that for a long time. I still remember 20 years ago when Hitachi realized that they could be looking at their hard drives and looking at tens, hundreds of thousands of hard drives, their life cycle, how they were operating, seeing what kind of things were happening near the end. And we all know how painful it is to have a hard drive die on your laptop, right? So this idea of getting a lot of data from a lot of similar machines and seeing what happens near the end when things are going wrong, and ideally, that's called predictive maintenance, and that's a big deal also.
Yeah, data. I don't know if you're familiar with Alexander Wang. He's like the big CEO. I think he just joined Facebook, but he kind of hit it big with data. And in my business, I'm always asking my partner, like, well, what's the data? What's the data? And at this point in time, it's just never been more valuable with AI, just feeding it to it. And once it has a history of a device, hot water tank, heat pump, whatever, it's like it can even locate, hey, it operated this way for so long, we need to adjust it for lifespan. And it's
Oh,
interesting.
yeah, I'll give you one quick example. So airplanes, it matters more often how often they land and take off than once they're in the air, right? There's not a lot of rumbling and rattling in the air. So we provide runtime maintenance rather than calendar time. Like if it wasn't very hot or cold and your HVAC system wasn't running a lot, it can go a lot longer before filter replacement than just a calendar time. So just right there, we know how often it was on and off, which nobody did. So you had to do things by calendar.
Yeah, interesting. Yeah, I grew up on a farm and it was always hours. A tractor could be like a 1960, but it had 500 hours runtime, and that's really the true indicator of what something's, got going on. Yeah, when I first bought my first multifamily down here, I didn't realize I called FPL. My electric bill was like super high, and I called them, and they said, "Oh, we can pretty much determine what's wrong with the house based off your usage." And I remember, younger me, I was just amazed. I started talking to them and picking their brain, and I realized they pinpointed basically what was wrong with that property just off their data. And it just blew my mind and it was like bad insulation, air conditioner, old air conditioner, things like that. But based off the time of day, they would, refer to the heat. And it's just amazing over time accumulating data, what you can come up with from data. So,
and just so you know, every utility until they have a smart meter, it was month late when they read your meter, and it was month increments. Smart meters are typically delivering 15-minute data, or certainly the machines in buildings with those 60-year-old Johnson Controls, Siemens Schneider, everything's based on 15-minute data. So you can imagine that if you have more and more granular, high-resolution data that a modern computing platform gives you microseconds, then you're going to make much better observations and yield better actionable data, things like predictive maintenance.
And I can just see the paths that go down, like with the Google Nest and whatnot. When you're not home, it automatically changes. So people are at work 8 or 10 hours a day, and their hot water tank is sitting in there boiling. And it's, once the connectivity's there, there's no reason, even if it can tell, hey, they're going to be home in 30 minutes, to warm the hot water tank up, you could save so much, consumption. So It's kind of interesting where this is all going. Like, we live in a connected world now.
Well, except less than 2% of commercial buildings are connected.
Yeah. So your guys' trajectory for growth is like astronomical, in the coming years. So if you had a magic wand to remove one barrier to growth, what would it be?
I think that there's a whole generation of young people that obviously care a little more about the climate, or more concerned about it, and that wish that they might be open to going into buildings, but the buildings just seem like the oldest thing. Do you really want to be a mechanical, electrical, plumbing contractor? So, that's actually a problem in the industry, right? We think that by having a modern tech computing platform doing all this in the industry, it's going to attract more young people. We're going to get that labor shortage resolved. Another barrier is the older folks being less familiar with technology, saying, hey, if it's broke, don't fix it. I've been doing it this way with my lousy data and my lousy connectivity for a long time. So there is a little bit of shifting to saying, oh my God, of course I want all this connectivity visibility, and I don't mind opening a browser and doing things.
Yeah, it's interesting. It's not like the sexiest like business idea, but it's much needed. Like just behind me, I'm on the beach here, our office in Fort Lauderdale. And when I used to live in one of the condos, in your hot water closet and AC, you had to have a moisture sensor. And I can't imagine how much that saved people in floods and whatnot. Whether the ACs are just notorious for leaking here, but it just, I'm sure, saved a lot of trouble. A few drops occurred before it was like gushing.
So this little EcoPort socket, kind of a sexy name, right? The EcoPort. That EcoPort socket, when we plug in our module, we can detect a leak anywhere in your home, not just the hot water heater, anywhere in your home where there's a hot water line leak, right? We can't have any visibility onto the cold water. But if you have half a gallon, a pint per hour, just dripping, we can detect it. We're trying to get even better at it with the AI. And that's just one example of a powerful use case that goes beyond the machine itself to the whole home.
Interesting. And you do that like with pipes or whatnot, like measuring temperature?
No.
Right
the water heater that has this socket delivers 2 bits of data. how much power it's using, and how much power I can ask it to use if I want it to use more energy. So as it cools off, when it's fully heated, it says, hey, if you give me a load up command, if you ask me to use more energy right now, I can't do it because I'm fully heated. So I have zero energy take capacity. And then as it cools off, it says, hey, I have more and more energy. It gets to about 900 watt hours and on its normal cycle. And then it says, hey, if you turn me on right now, I'll use 900 watt hours. Oh, at 925, I'm going to turn myself on. So that's typically the pattern. So we can see how slowly it's cooling, and we know the outside weather and the ambient air temperature, and all we do is measure a change in that pattern. Plus, we know that between midnight and 4 in the morning, it's highly unlikely that you're using any hot water. So we compare that midnight to 4 in the morning slope of how much it's cooling, and if that increases, we know there's a leak.
Interesting.
Data. No sensors, no pipes, just the water heater itself saying, I am needing to heat a little bit more often than I was before.
So I kind of want to go down the path of like you mentioned Oregon, I believe California, and as far as implementation of connectivity, the USB port, what does that look like nationwide? Like more and more states are kind of encouraging that or mandating that?
Well, I talked about Denver. I talked about the commercial building specification that's doing it. So, yeah, it's going to happen. Washington and Oregon are usually not seen as the progressive states, right? It's California, Texas, Massachusetts, and New York. So it's really exciting that they've led the way. But, you know, we hear rumors, North Carolina, Colorado, the whole state, New York. And again, I think that, I mean, Mitsubishi just announced 2 months ago, you can go on their website, you can go on our website and see the link. So not only central system water heaters for multifamily buildings like you're familiar with, but now there's a Mitsubishi heat pump that's called the Smart Multi, and it's for HVAC. And they can use our box, you can see it on their website, and it gave them the grid certification so they can get $10,000 to $14,000 of incentives from California just because they have our box with this socket. So California only requires it on new construction, not every device in the state. So it's required on new construction or large retrofit. But yeah, I think as people discover that this gives a competitive alternative way to get to the machine rather than just a manufacturer method, it allows you to choose cellular, LoRa, satellite even in agricultural situations. So yeah, but Washington and Oregon somehow led the way.
Nice. So, you know, coming up to an end, we got about 10 more minutes here. Is one lesson you wish you knew 5 years ago? If you can go back 5 years, what's one lesson you wish you knew?
Yeah, I wish I knew that utilities are really hard to sell to, and we always had this vision of going directly to commercial buildings. At the time, BACnet and Modbus were hard. So I remember 5 years ago, I told my team, I said, hey guys, we already have cellular. We want to get to these big commercial building rooftop units and boilers and chillers and HVAC systems. What if we could talk BACnet and Modbus from the cloud through our system? Then we could connect to any machine. And my team dug into BACnet and Modbus, and they said, man, it's so old and, you know, slow. We don't really want to do that. Well, if we'd done it 5 years ago, we could have revolutionized this industry and done everything I'm telling you about right now that we've only been doing for a year. So that's what I wish I had pushed.
So, like having that access to those two, I guess, almost like code scripts or whatnot. Your
protocols, right? Protocols.
Yeah, your target audience just exploded when you had that capability.
Yep.
Nice. Where do you see Skycentric in 5 years?
Well, we want to be, you know, like Bill Gates said, right? A computer on every desktop. Well, we want to have a super skybox in every building, at least one.
Nice. And your hurdles to growth. Talked a little bit like remove magic wand, remove a barrier. So, what are like your main hurdles now to get to that point? Eco port in every appliance.
Yeah. So, the EcoPort in every appliance we have less control over. That's why we're super excited about the Super Skybox. Right, this can go into any building right now, old or new, and connect to any machine right now. So that's really exciting, right? Like this has been kind of dependent on regulation, like Washington and Oregon. This is ready to go, and that's why we're excited to be starting to work with channel partners, again, that provide services that have customers where it's millions and billions of square feet. That's how we can scale. So, yeah, in terms of the challenges ahead, right? It's going to be growth. It's going to be supporting those channel partners to be really successful. It's going to be increasingly building the tools that make it plug and play. So we have a fun little expression. When you get one of our devices, right? You can go to our website, you'll see these 3 devices. And when you get one of those devices and plug it in and it talks to our cloud, the little LED on it turns blue. So we call it getting to blue. So we're trying to make it easier for this super skybox to get to blue, to be wired correctly by somebody who isn't necessarily that technical, and then it goes to our cloud, and the very technical engineering partners we have can now see it and can be doing everything remotely, right? So fewer truck rolls, plug and play, send it through the mail, install it, and then have these tools that make it easy to ingest all of that equipment. Because at the end of the day, I'm waving my hand a little, right? Yes, it is true that different equipment has different error codes and different data points. But we've been working with the national labs, with the Linux Foundation, with the Coalition for Smarter Buildings, and there's a lot of people who have been attacking this problem, making standards for how you name those pieces of equipment. And very soon, Mitsubishi, Daikin, the equipment makers, are going to start saying, hey, people are finally using connected machines. We're going to follow the standards, not just make our machines have our own proprietary random way, because the first machine maker who follows the standard is going to sell more machines, because everybody's going to say, hey, when I plug this machine in, it's plug and play to these open interoperable standards. If I use this machine, well, I got to go in and manually map stuff.
Interesting. So you mentioned like channel partners. That's like a big deal. It's like getting in with people who are already in these buildings and whatnot, and including your services.
Yeah, so we've been invited by a number of these companies to install super skyboxes in their headquarters so they can bang on the tool, bang on our platform, and then say, hey, this is as great as we were promised, and we're going to sell it to our customers.
Nice. Well, that about wraps it up. Yeah, I appreciate you coming on. I learned a lot. So I'm going to stop the recording.